So hello everybody, this is Shivam back again with a new video on a video series of CSIR and GRF Sciences. So in this video I'm going to discuss about some very important topics from the CSIR syllabus. Basically these topics are suggested by one of my junior called Sagar. His name is Sagar. Okay, so let's start the video first. Before that, this is my channel. Here we get lots of video regarding CSIR, NET, JAM, GATE. Okay, so let's start then. So today we are going to discuss about Vorticity. Okay, now what a Vorticity means? Vorticity is simply means a kind of rotation of a fluid on the earth's surface, whether it is in the air, whether it is in the water, whether it is a part of atmosphere or ocean. Okay, now we have different types of Vorticity. Something is called planetary vorticity, also known as Earth's rotational vorticity, and then we have absolute vorticity, potential vorticity, relative vorticity. So lot to know, lot to discuss. Before we begin, let's see what the basic concept of vorticity is. So basically अगर तुम देखो, this vorticity is nothing but a rotation. Okay, a rotation of a something around axis. Okay, now we know that equator, this is your Earth's axis, which is tilted 23.5, and this is your equator. Here we have equator. Now equator has maximum distance from the axis, right? And let's assume the distance of equator, Earth's surface on the equator is around 6400. Okay, let's assume this. If there is a point exactly at geographical north, its distance from the equator is minimum, and for equator it is maximum, right? Now to cover this rotation, distance traveled by a point at equator is maximum, right? And a distance covered by a point at a pole is minimum. Is this clear? Now both rotates in a same interval of time. Yani if a person is standing over here and if a person is standing exactly on the pole, both covers a one complete rotation in 24 hours. But here distance is more. So if distance is more, that means here velocity is also more, right? Velocity is what? Velocity is distance by time. So we can say that time is equal to distance by velocity, right? Yani at equator, velocity is more than that of the pole because it has to cover a long distance. Now, I think this is clear to you. So around 1647 kilometers per hour, this is the basically, or miles per hour, this is the velocity at equator, while at pole it is very less. Now let's see what a planetary vorticity is. So we know that because of this Earth's rotation, we have Coriolis force also, and the value of Coriolis force at equator is around 0. Okay, at equator this Coriolis force at equator, okay, Coriolis force, equatorial Coriolis force is equal to 0. How? We know that the formula of Coriolis force is this one, 2 omega v sine theta, and the value of equatorial latitude is 0. So 2 omega v sine 0, and the value of sine 0 is what? Sine 0 is what? It is 0. While at a pole it becomes 90, and for 90 the value of sine theta is 1, and when you multiply 2 omega v with 1, it has the maximum value. So mathematically we can say that Coriolis force at equator is 0 because sine theta is 0, and at pole it is maximum because sine theta is having maximum value. Now one more thing, if suppose somebody is standing over here at equator, in this case there is no rotation along the vertical axis. It is basically rotating across the vertical axis because this person is standing at 90 degree to this axis of rotation, right? So there is no along rotation, and that's the reason why planetary vorticity over here is 0, because there is no along vertical axis rotation. For for a planetary vorticity, we require a rotation along the axis, while a person who is standing exactly on the say geographic north, it has maximum vertical it has maximum rotation along the vertical axis, right? It is basically covering the entire this thing rotation in 24 hours, and he's moving like this. Simply it is moving like this in 24 hours. Okay, so is this clear? Planetary vorticity is maximum at pole and zero at equator. Is this clear? So at equator it has zero value. Okay, because there is no rotation along the vertical axis. Okay, now planetary vorticity is due to Earth rotation and Coriolis effect. Okay, then we have second vorticity called relative vorticity. So relative vorticity is what? Suppose right now I am standing on say 15 degree north. The latitude of Goa is around 15 degree north. Okay, right now I am not rotating with respect to the earth. I am just sitting on my chair. So right now I have certain planetary vorticity, but if I start rotating at this same axis or at same place like this, I am sitting over here and I start rotating with respect to the earth's rotation, then I will get some relative vorticity. Is this clear? So for a relative vorticity, rotation is required with respect to earth's rotation. Okay, now is this clear or not? Tell me first. Is this clear? So if I have a rotation somewhere on the earth, I will get some relative vorticity. Now this relative vorticity plus planetary vorticity is equal to absolute vorticity. The sum of these two is called absolute vorticity. Okay, so we can say that this absolute vorticity is basically sum of Earth's rotation, that is planetary vorticity, and relative vorticity, and it is denoted by say AV. Okay, which is equal to PV plus RV. AB is equal to PV by RV. So in different books we get different symbols. Okay, is this clear? Now here this rotational vorticity is what? This is called Coriolis parameter. Okay, this relative vorticity is nothing but Coriolis parameter. It is also denoted by FC, and it is equal to 2 omega sine theta. If you multiply, you can write like this also. Somewhere it is written like this. If you multiply this with B, you will get Coriolis force. Without B, it is considered as Coriolis parameter. Okay, is this clear? This theta is basically a latitude. So if you get numerical like this, they will simply give you the value of planetary vorticity and they will give you latitude. Just you have to put this formula to find Coriolis parameter and just add this Coriolis parameter with PV. PV is what? Planetary vorticity. You will get absolute vorticity. Okay, is this clear? Now absolute vorticity is conserved. So it means if one is increasing, in that case another should decrease. If planetary vorticity will increase, it should decrease, and if this one is decreased, that means it should increase, because absolute vorticity is conserved at a given latitude. Okay, so it must be the same, and we know that this is the sum of these two. So if one is increasing, that means another is decreasing. Right now we know that if we move towards the pole, this planetary vorticity will increase. Pole per this planetary vorticity PB is maximum. At equator it is minimum, 0. It is 0, right? This PV is 0 at equator. Equator per it is 0. At pole it is maximum. that means this relative vorticity at equator is maximum. It is maximum because the sum is constant. So if this is maximum at a pole, that means it is minimum at a pole per it is minimum. Is this clear? Is this clear or not? Planetary vorticity is maximum at a pole, minimum at equator. Here relative vorticity is maximum at equator and minimum at pole. Now let's see a real life example. So here we can see that there is a upper level wind. It's basically a jet stream, say polar jet stream, which is moving from west to east. It is a permanent jet stream. Okay, now it is showing some meandering. That means it is a kind of Rossby wave over here. Okay, now the question over here is, if the wind are moving from north pole towards the equator, is the wind gaining or losing planetary vorticity? Yeah. So if you are moving towards equator, that means planetary vorticity will decrease, since there is no rotation along the axis. Here we have rotation across the axis at 90 degree. So we are losing planetary vorticity. We have this type of question in CSIR. Please note it down. We have this type of questions. If there is a decrease in planetary vorticity, that means at equator there is a gain in relative vorticity. Relative vorticity will increase, right? Now let's see what a positive relative vorticity is, what a negative relative vorticity is. Now this is our jet stream, which is moving from west to east in some kind of meandering form. Okay, now how to know whether this is a relative vorticity positive or not, or whether it is negative or not? So what you do is, I have a simple technique for this. So this is your point 1. Just put your right hand in this diagram. Okay, put your right hand just above here. So just like this. Suppose these are our 4 fingers. This is my right hand, this is my thumb. I am putting my hand like this on the first point. Now we can see that here my all 4 fingers are pointing in the direction of wind. Point to be noted. Here all my 4 fingers are pointing in the direction of wind, and my thumb is in the upward direction, away from this screen. It is away from the screen, no? So in this case, this is your positive relative vorticity. If you have such situation, that means it is a positive relative vorticity. Negative relative vorticity means, again just put your right hand over here. So in this case your fingers are like this, all 4 fingers, and this thing, your thumb is in the screen, towards the screen. Just put it over here at point 2. So in this case you can see that your thumb is going inside the screen, and this is your negative relative vorticity. So is this clear or not? Is this clear? How to understand whether the vorticity is positive or negative? If we always use our right hand, and we always put all the 4 fingers in the direction of wind. Here also it is in the direction of wind. See, direction of wind, both are pointing in the direction of wind. Here also it is in the direction of wind. In this case, at point 1, our thumb is pointing away from the screen, so that means it is positive. And here it is pointing inside the screen. Okay, so that means it is negative. Now I hope this is clear to you. Now moving to next. See, this is very easy. I will make it clear to you. Now moving to the next. Okay, so if the wind are moving from north pole towards the equator, wind is losing planetary vorticity. That is correct. Equator की तरफ जाने पर planetary vorticity will decrease. The absolute vorticity is conserved, so what happened to the relative vorticity? We know that absolute vorticity is always conserved. That means your relative vorticity will increase, and if it is increasing, that means it is more positive. Okay, now it is more positive. So increase of relative vorticity is what? Matlab, at this point, the rotational speed of a body with respect to Earth is increasing, while here the rotational speed of body with respect to Earth is decreasing. That's why it is negative. Okay, so you can say that the correct answer over here is A. It becomes more positive. That means it will increase. Now let's use this concept to solve real life problems. Okay, to understand this behavior of upper level jet streams and all. Now in this case we can see here we have high pressure zone. This is your low pressure zone. In the case of high pressure zone we have anticyclonic conditions, right? Here we have anticyclones. This is your cyclones. In a case of cyclones there is a convergence on the surface and divergence on the top. This is your divergence zone. Here we have divergence on the surface and convergence on the top. One more thing, as you move towards the low pressure zone, you can see the decrease of value, right? 99.2 kilopascal, here 99.6 kilopascal, while over here, as you move away from the core, there is decrease of value. Here towards the core and here away from the core, there is a decrement of values, right? Now let's see here. Suppose we have a mid-latitude cyclone. We know that there is a theory for mid-latitude cyclones. This theory is called polar front theory. Polar front theory. We know that these mid-latitude cyclones or temperate cyclones is basically a kind of cyclone which is generated by fronts. It is not developed by convections. Okay, it is generated by frontal formations. Okay, and it can generate on the ocean as well as on the land. Okay, now let's see. This is your jet stream. Okay, right now it is in the form of Rossby waves. Okay, now it is moving from this point to this point in a meandering manner. Okay, now at point 1 and 2 and 3, these points are linear. This entire path is linear. So there is no relative vorticity, right? Because it is not rotating with respect to Earth, no. Then only it becomes linear. See, right now if you see myself from space, you can see me that I am going like I am moving basically in a straight line. अगर हम यहाँ बैठे हैं suppose and you are in the space, तुम हमको देख रहे हो, तो तुमको क्या लगेगा? You will see that I am moving in a straight line. But what happens if I start rotating over here on the Earth's surface? So I am moving in a straight line, at the same time I am rotating with respect to Earth's surface, both. Over here, since the line is straight, the path is straight, that means here we have planetic vorticity, but this rotational vorticity is relatively less. Okay, it has some component, but it is very less. Okay, now let's see over here at point 3 and 4 what happens. So at 3 and 4 we can see there is a certain curvature, right? And if there is a curvature, that means here we have now increase in relative vorticity. That's why we are getting curvatures, right? There is a certain relative vorticity. Now whether this relative vorticity is positive, whether it is negative, whether it is associated with convergence or divergence, इसको देखते हैं. So ये देखो, तुमने ये कॉन्सेप्ट देखा होगा, ballet dancer. Ballet dancer, what they do is to increase their angular momentum, okay, angular velocity. What they do, they fold their hands. So this is the first case for a ballet dancer, and second case is say over here. Here their hands are folded. Okay, so if you fold your hands, basically you are shifting the mass towards the axis of rotation. This is the axis of rotation. Okay, so if you shift the mass towards the axis of rotation, your rotational velocity will increase. And the same concept is used by ballet dancer. When they fold their hands, their rotational velocity increase. When they simply basically make their hands long, then in that case their rotational velocity decreases. Okay, so if there is convergence, convergence means what? Converge matlab folding hands. Let's assume convergence is folding hands, because convergence is also putting everything together, right? So convergence means, say, folding hand, and we know whenever we, this is your convergence, it is means folding hand, and we know whenever we converge hand or fold the hand, the rotational velocity will increase. Rotational velocity will increase. Okay, rotational velocity will increase. Is this clear? So at this point A, let's see. At this point we can see that since this is moving towards a low latitude, this is your high latitude, this is your low latitude. Okay, say this is a jet stream, it is moving from this point to this point. So at this point, since this is low latitude, that means as you move towards a low latitude, planetary vorticity will decrease and relative vorticity will increase. And if there is an increase in relative vorticity, that simply means there is an increase in rotational velocity. And if there is an increase in rotational velocity, that means there is a convergence. Is this clear? So here we have convergence. See, convergence is occurring over here. Why there is a convergence? Because relative vorticity is increasing, because rotational speed is increasing. So if rotational speed will increase, it will converge everything close to the central axis. ओके, जैसे सेम बैले डांसर का एग्जांपल याद रखो, हाथ फोल्ड करने पर उनका रोटेशनल वेलोसिटी इंक्रीज हो जाता है, राइट? मास को वो लोग क्लोज आ रहा है, राइट? सेम वे हियर एवरीथिंग इज शिफ्टिंग टुवर्ड्स द सेंट्रल एक्सिस, सो रोटेशनल वेलोसिटी विल इंक्रीज, यानी देयर इज अ कन्वर्जेंस इन द अपर एटमॉस्फेयर. अपर एटमॉस्फेयर करने का मतलब जेट स्ट्रीम के हाइट पर वी हैव कन्वर्जेंस नाउ. Now if there is a extra convergence at this point, it will suck air from all side and it will put all this air inside this cylindrical shape structure. सारे air को इस cylindrical shape structure में डाल देगा. Okay, so that means now air is moving downward with a dry adiabatic movement, and whenever we have dry adiabatic movement downward, that simply means warming of air parcel. Warming of air parcel means no cloud, calm conditions. And see, this is anticyclone. So yeah, anticyclone में यही तो होता है. So everything is converged at upper air, and now it is getting diverged at the earth surface with calm conditions, with high pressure conditions. Why there is a high pressure? Because everything is moving down, it is subsiding down. Now is this clear to you? So here we can say that this region is associated with high pressure because here we have convergence of wind. Now let's see, this is moving like this. Now this jet is moving like this. Okay, now if it has constant relative vorticity, in that case it will keep circulating at this point. But now you can say that it is moving like this. ये कुछ ऐसे मूव कर रहे हैं. अगर constant रिलेटिव वोटोसिटी होता है तो क्या होता है, ये एक सर्कल में मूव करते रहते हैं, बट देर इज नो कांस्टेंट रिलेटिव वोटोसिटी. नाउ इट इज मूविंग सिंपली लाइक दिस. ओके, एट दिस पॉइंट हियर वी अगेन सी दैट दिस ट्रांजिशन जोन बी, हियर नाउ इट इज स्टार्ट मूविंग टुवर्ड्स अ पोल. सो प्लेनेटिव वोटोसिटी विल नाउ स्टार्ट्स इंक्रीजिंग एंड रिलेटिव वोटोसिटी स्टार्ट्स डिक्रीजिंग. एंड इफ देर इज अ लेस रिलेटिव वोटोसिटी, मतलब there is no folding of hands, that means there is a divergence instead of convergence. देखो, जब एयर हाथ को फोल्ड कर रहे थे तो स्पीड बढ़ जाता था, कन्वर्जेंस होना शुरू होता था. अब क्या हो रहा है कि वी आर मूविंग टुवर्ड्स अ पोल. सो इन दिस केस योर प्लेनेटिव वोटोसिटी विल इंक्रीज, दैट मीन्स रिलेटिव वोटोसिटी शुड डिक्रीज बिकॉज एब्सोल्यूट वोटोसिटी इज कांस्टेंट, राइट? बिकॉज दिस इज इक्वल टू एब्सोल्यूट वोटोसिटी, नो, एब्सोल्यूट वोटोसिटी. So that means it is decreasing. Is this clear? Relative vorticity is decreasing, and if relative vorticity will decrease, that means there is a divergence of wind in the upper atmosphere. And see, there is a divergence of wind, and it is associated with surface low. Surface पर we have low pressure. Okay, Now why there is a low pressure on the earth surface? Again the reason is everything is converged at the earth surface. So everything is sucked in and then it is diverged at the upper atmosphere, at tropospheric height, at the jet stream height. And because of that you will get divergence zone and here we will get a convergence zone. So you can see that here it is associated with divergence, and divergence means low pressure on the earth surface. Okay, now is this clear? Okay, one more thing. We know that there is a high pressure at higher latitudes and at lower latitudes close to the equator we have low pressure zones. In the polar regions we have high pressures. Okay, is this clear or not? Is this clear? One more thing, this high pressure and low pressure again depends upon whether there is a high relative vorticity or whether there is a high planetary vorticity. अभी हम लोग देखें, in this case planetary vorticity is decreasing and relative vorticity is increasing because it is moving towards the equator. Here in this case relative vorticity is decreasing and planetary vorticity is increasing. So now you can understand this map, why we have somewhere ridge like structure, somewhere trough. So ridge is associated with high pressure. Okay, ridge means there is a convergence of wind in the upper atmosphere. If there is a convergence on the upper atmosphere, that means there is a opposite on the earth surface, so divergence on the lower atmosphere on the earth surface, and in this case you will get high pressure zone. Simply over here you have divergence in the upper atmosphere, that means there is a divergence in the lower atmosphere, sorry, convergence in the lower atmosphere. Here we have divergence and here we have convergence, so it is associated with a cyclonic activity. Okay, now this you can see that this is your what, this is what, this is what, this is your warm front, this is your cold front, another blue one is your cold front, this is your cold, this is your warm, and this cold front we know it is moving, having a fast speed than the warm front, so it will capture this warm front after some period of time. This is your cold front, right, cold front, and this is your warm front. Right now warm front is ahead of cold front, but the speed of cold front is more than the warm front, so it will capture, and once it will capture it will form a occluded front over here, and occluded fronts create mid latitude cyclones, we know that. Okay, now let's see, I have a question. Okay, so this is your upper level jet stream path. Okay, now predict the location of high pressure low pressure centers at the earth surface. Where do you think a high pressure area will form? So here we have 3 points A, B and C. Let's see where a high pressure forms. Now for the formation of high pressure on the earth surface, what we need see, from this photo we can say that if there is a convergence in the upper atmosphere, that means there is a high pressure on the earth surface. So we have 3 points A. At point A, let's see, here it is moving from low latitude to the high latitude, so planetary vorticity will increase because we are moving towards high latitude. Relative vorticity will decrease because we are moving towards a high latitude. Okay, now if relative vorticity is decreasing over here, that simply means there is a divergence. We are unfolding our hands, so रिलेटिव वोर्टिसिटी डिक्रीज कर रहा है, यानी डाइवर्जेंस है, और जब भी डाइवर्जेंस होता है तो अर्थ सरफेस पे क्या होगा, लो प्रेशर. अगर इस हाइट पर डाइवर्जेंस हो रहा है, दैट मीन्स ऑन द अर्थ सरफेस देयर इज अ लो प्रेशर. सी, डाइवर्जेंस इज एसोसिएटेड विथ लो प्रेशर ऑन द अर्थ सरफेस. नाउ एट दिस पॉइंट लेट्स सी, हियर इन दिस केस इट इज मूविंग फ्रॉम हाई लैटिट्यूड टू लो लैटिट्यूड. हाई लैटिट्यूड पर वी हैव व्हाट, it is moving from high to low, so planetary vorticity will decrease but relative vorticity will increase. And in this case if relative vorticity will increase, मतलब यहाँ ज़्यादा wind close आ जाएंगे, there is a convergence, there is a folding of hands, and whenever we have convergence in the jet stream, that means there is a high pressure on the earth surface, so here we get high pressure. And similarly like this A, here we have low pressure. Now you can see that these are the answer. So predicted location of high and low pressure centers at the earth surface you can see now. So this is all about absolute vorticity, relative vorticity and this planetary vorticity. You have now formula for this numerical problems also. This absolute vorticity AV is equal to relative vorticity plus planar vorticity. They will give you planar vorticity value. Relative vorticity is nothing but Coriolis parameter, so RV is nothing but 2 omega sine theta. Okay, plus planar vorticity. You can use this formula to solve various types of numerical. Now there is another type of vorticity called planetary vorticity. Sorry, potential vorticity. Potential vorticity. Now what it is? So this potential vorticity is defined as a vorticity, absolute vorticity divided by depth, that is delta J, of the column of air that is rotating. So suppose here we have rotational motion, right? So this is the depth of the column which is rotating. When we divide this absolute vorticity, which is a sum of relative plus planetary vorticity, with delta Z, you will get this potential vorticity, potential POT. चलो ये हम लोग यूज कर सकते हैं. So formula is what for potential vorticity? This potential vorticity is equal to absolute vorticity by delta Z, and we can also write it like this: relative vorticity, which is nothing but your Coriolis parameter, same thing, FC से denote करते हैं, plus planetary vorticity by delta Z. And again this is a constant, this will be constant. Okay, if absolute is constant, this height is also constant value, no? So this is the formula for potential vorticity. Okay, now that's it. I hope this is clear to you. Now ये मैप समझ में आया होगा, why there is a recent of how there is increase and decrease of relative vorticity. याद रखना, it's very easy. Now let's recap once again. अब देखो यहाँ हम जल्दी रिकैप कर देते हैं. सो प्लेनेटरी vorticity के केस में वी हैव मैक्सिमम प्लेनेटरी vorticity एट पोल, क्योंकि वो रोटेशन जो हो रहा है वहाँ एक्सिस के अलोंग हो रहा है, हियर एक्सिस के अक्रॉस हो रहा है. सो इसलिए सबसे ज़्यादा पोल पर होता है, यहाँ सबसे कम होता है. देन व्हाट इज रिलेटिव vorticity? रिलेटिव vorticity इज नथिंग बट a rotation of any particular body with respect to the earth surface, that is your relative vorticity. Relative vorticity अब जानिए, अब इन दोनों को जब सम करेंगे तो एब्सोल्यूट vorticity निकलेगा. एब्सोल्यूट vorticity हमेशा कंजर्व होता है, दैट मीन्स वन, इफ वन विल इंक्रीज दैट मीन्स अनदर विल डिक्रीज, एंड इफ इट विल डिक्रीज सो इट मीन्स दिस विल इंक्रीज. ओके, नाउ यहाँ हम रूल बताते हैं. यहाँ हम लोग क्या करते क्या है कि इस पॉइंट 1 पर अपना राइट हैंड को रखेंगे और हमेशा ऑल दिस 4 फिंगर्स आर पॉइंटिंग इन द डायरेक्शन ऑफ विंड. सो इट इज़ पॉइंटिंग इन द डायरेक्शन ऑफ विंड. सो इन दिस केस अगर हाथ रखते हो स्क्रीन के ऊपर, तुम्हारा जो थंब होगा, दिस थंब विल पॉइंट अवे फ्रॉम द स्क्रीन. अवे फ्रॉम द स्क्रीन अगर पॉइंट कर रहा है, दैट मीन्स पॉजिटिव रिलेटिव vorticity. पॉजिटिव रिलेटिव vorticity का मतलब होता है कन्वर्जेंस. कन्वर्जेंस का मतलब होता है कि नाउ वी हैव हाई प्रेशर ऑन द अर्थ सरफेस, हाई प्रेशर ऑन अर्थ सरफेस. ओके, इस केस में क्या है कि अगेन हाथ को रखेंगे और नाउ इन दिस केस राइट हैंड अगर रखते हैं तो हमारा थंब नीचे जा रहा है अगर चारों फिंगर्स को विंड के डायरेक्शन में रखें तो. ओके, सो ऐसे कुछ रखेंगे, ये हो गया नीचे, ये हो गया थंब, इट्स लाइक दिस. इस चीज़ को यहाँ रखेंगे. तो निगेटिव vorticity का मतलब क्या, हाथ को अनफोल्ड कर रहे हैं तो मास दूर जा रहा है सेंटर ऑफ एक्सिस से, तो हमारा जो रोटेशन का स्पीड है वो कम हो जाएगा. अगर रिलेटिव vorticity डिक्रीज कर रहा है मतलब प्लेनेटरी vorticity इंक्रीज करेगा. और ऐसे भी हम लोग देख सकते हैं कि इट इज़ मूविंग टुवर्ड्स अ हाई लैटिट्यूड, सो प्लेनेटरी vorticity विल इंक्रीज. ओके, इस केस में हम लोग देख लिए थे. यहाँ हम लोग देख सकते हैं कि वी आर मूविंग फ्रॉम हाई लैटिट्यूड टू लो लैटिट्यूड, दैट मीन्स प्लेनेटरी vorticity विल डिक्रीज एंड रिलेटिव vorticity विल इंक्रीज. अगर रिलेटिव vorticity इंक्रीज करता है तो होता है कन्वर्जेंस. यहाँ अगर कन्वर्जेंस होगा तो हाई प्रेशर होगा अर्थ सरफेस पर. फिर ये देख रहे हैं कि नाउ इट इज़ मूविंग लाइक दिस. इसका मतलब कि जो रिलेटिव vorticity यहाँ था वो कांस्टेंट नहीं रहा. नाउ इट इज़ मूविंग टू द पॉइंट 4 and 7, इनके बीच में ट्रांजिशन जोन में आया. यहाँ क्या हो रहा है कि नाउ अगेन दिस रिलेटिव vorticity इज डिक्रीजिंग बिकॉज वी आर मूविंग टुवर्ड्स अ हाई लैटिट्यूड रीजन. तो वहाँ प्लेनेटरी vorticity इंक्रीज करेगा और रिलेटिव vorticity डिक्रीज करेगा. और ऐसे केस में डाइवर्जेंस होता है विंड का व्हेनेवर वी हैव डाइवर्जेंस ऑन द जेट स्ट्रीम हाइट, इसका मतलब यहाँ होगा कन्वर्जेंस। और ये फार्मूला है पोटेंशियल वोर्टिसिटी क्या होता है, पोटेंशियल वोर्टिसिटी इज नथिंग बट absolute vorticity divided by the depth of the column of air that is rotating. So yeah, that's it. I hope this is clear to you. Okay, thank you Sagar for asking this type of question, and you everybody, if you have such questions, कुछ भी टॉपिक हो, अगर कोई प्रॉब्लम हो, जस्ट टेल मी. इफ आई हैव टाइम आई विल डेफिनेटली मेक द वीडियो. Okay, nowadays I am quite busy from 9 to 6 o'clock. I am busy in this in my institute, okay, and doing some experiments and all. And after that I have to make my this thing. I have to cook some food for me and like some personal works. Okay, इसलिए टाइम नहीं मिल पाता है, sorry for that. So okay, bye, see you everybody.